Welcome to Mickey Study Circle channel. In this video, we shall see how to do the computer drafting of orthographic projection of lines. So we can call this problem to be the end projector problem. So now let us read this problem statement. A line AB has its end A 20 mm above HP and 30 mm in front of the VP. The other end B is 60 mm above the HP and 45 mm in front of VP. The distance between the end projectors is 70 mm. Draw the projections of the line and determine its true and the apparent length, true and the apparent inclinations. So if we just look at the problem, what we can do is we can analyze that the endpoint details are given, or the position of this endpoints, that is the two extreme points of the line AB, is given to us. It is above HP and in front of VP. And also the distance between the end projectors is given. The true length of the line nor the apparent length, the true inclination nor the apparent inclination is not given here. So now, by keeping the data of the location of the endpoints in the first quadrant and also the distance between the end projectors, how we can determine the true length and the apparent length of the line, let us see. So we'll begin the problem by drawing the XY line of thickness 0.18 mm. So it could be a line of any arbitrary length. So we will annotate this line as X and Y. Also the planes as VP and HP. So we'll begin the problem by drawing the location of the point A. So we will draw the projector line of thickness 0.13. So it is 20 mm above HP. So let me record the front view of the point A, and then it is 30 mm in front of VP. So let me record the top view of the point A. So now let me draw the locus of the point A. So the locus of point A in the VP, and this is the locus line of the point A in the HP. So let me annotate these. So this is A dash, which is the front view of the point A, and this is A, which is the top view of the endpoint A. And this line is the locus of A in VP, and this is the locus of A in HP. So now this data is given. Also, now let me try to locate the locus of the endpoint B. So we will just try to locate the locus of the endpoint B. So for that purpose, we will just draw the locus line by using the offset option. So in this offset, I'll be selecting this line to be the offset. So I do know that distance. So let me just show the distance here. So this is 20 and this is 30. So the other point, end point B, is 60 mm above HP. So I can just offset the XY line at a distance of 60 mm, or this particular locus of A dash at a distance of 40 mm from this point as the reference. So considering the locus of A as the datum, I can offset this locus line to get the locus of the endpoint B. So what I'll do is I'll go for the offset option. I'll select the locus line and enter the distance of offset as 40. It is asking me the direction, either upwards or downwards. So obviously it should be upwards because it is the front view of the point B. It is 60 mm above the HP. So I'll be showing this distance. So it is showing me this distance as 40. I can just delete this distance and show the entire distance. So this entire distance is 60 mm. So this is the locus of B in the VP. So let me annotate this locus line. So this is locus of B in the VP. So the similar procedure will be adopted for drawing the locus of B in the HP. So what I can do is, it tells that it is at a distance of 45 mm in front of VP. So here, this locus line is already at a distance of 30 mm in front of VP. So adding another 50 mm will be giving me the locus of point B. So what I'll do is I'll select the offset option and select this locus of A and enter the offset distance as 15 and then indicate the direction downwards. And I'll come out of the option by clicking the escape key or using the right click of the mouse button. So select the smart dimension and select the XY line and this line, and you can just see that it is at a distance of 45 mm. Correct. So this is the locus of B in HP. So I do know that the point B1 and B dash will be lying on this line. The point B2 and B will be lying on this line. Correct. So let me just adjust the annotation so that it is visible clearly. So now, after having known this, the distance between the end projector, that is what the distance which is parallel to the XY line between the A and B points is equal to 70 mm as per the problem statement. So keeping this in mind, what I'll be doing is I'll just offset this line at a distance of 70 mm. So what I'll do is I'll select the offset option again. I'll be selecting this line and then offset to a length of 70 mm. So it is 70. So in this direction, correct? So I'll change the line type to continuous line. So I can use the extend to next option and then complete the projection of the line. So this is where the point B dash and B will lie. So this is what is the location of the end points B in both VP and HP respectively. So since it is the projector line of B, I can just understand that it is B dash and B points. That is, the front view of the point B and the top view of the point B is on this same projector line. So let me draw the apparent length of the line by joining the two extreme points of the line, that is A dash to B dash, that is this end point, and then A to B. This is one more end point. So using the smart dimension, so select by 2 points. So you're getting the apparent length of the line AB in the front and the top views. Correct? So now the apparent lengths are marked. So with this, we have to mark the true length. So what is the procedure for that? So if you just get back to the previous videos, we can understand the procedure to draw the true inclinations when the apparent inclination is given. So we'll follow the same procedure. So what I'll be doing is I'll be selecting the arc by center point. So consider this as the first point and the second point as B dash, and then ensure it is a continuous line of thickness 0.13 and cut an arc until it is intersecting the locus of A in the VP. So the thickness shall be 0.13, the projector line thickness, and then from this endpoint of the arc, I'll be intersecting it to the locus of B. So if I just draw a line from this point to this point, I'm getting the true length of the line in the horizontal plane. So this is B2. This point is the point of intersection that you get to see. This is what is B2 dash. Right? So now it is time for me to locate B1 and B1 dash. So we'll follow the procedure. So what is the procedure? So let us just indicate the leader, that is the arrow for this projection lines. So first we have drawn the arrow from here and then the projector downwards, correct? So this is the step. But whereas whenever the true length is given, the apparent length has to be drawn, the procedure is reverse. Okay, so now we will go for the true length of the line in the vertical plane. So for that, what is the procedure? I'll select arc by center point, correct? I'll be selecting arc by center point. So what is the radii of the arc? AB. This is the radii of the arc, and I'll be cutting an arc until it is intersecting the locus of A, correct? Until it is intersecting the locus of A, and then from there I'll be drawing a line perpendicular to the locus of A in the VP. Until it is intersecting the locus of B here. And then from that point I'll be joining to the end point A. So it is almost overlapping, so but still it is having so much of difference. When you zoom it out, you can just see the difference. So this is the procedure. So let me just fit the sheet to the screen and then zoom it out for better clarity. So go for the reader option and then go for the properties, change the color of the arrowhead to black. So this is the direction in which the projector was drawn, correct? Okay. So now what we can do here is we will first annotate the lines. So this is B and this is B2. And what is this point? This point is the top view of the point B1, correct? And then this was B1, the front view of the point B1. So this is point B1 dash. So this is point B1 dash and this point is B dash. This is B2 dash and this is B1 and then B2 is here, B2 and this is B. So we have identified all the points. So we will just use the trim option to show that this particular horizontal line is the front and the top views of this line. So I'll be trimming this line also. So I'll select the line option and ensure it is a continuous line. So AB2, A dash B2 dash is the front view of this line AB2 and AB1 is the top view of this point of this line, that is AB1 dash, A dash B1 dash, correct? So let me just fit this to the screen and measure the true length. So the true length should be the same. So this is 82.101, which is the true length. So let us measure this. Yes, it is correct. So it is 82.01 even in this plane. So now measuring the apparent and the true inclinations. So select the angle between the true length and the locus line, 29 degrees, and the true length and the locus line, 30 degrees, or a difference of 1 degrees between the true inclination and the apparent inclination. So select the angle between again, measure the angle between the true inclination and the apparent inclinations. To measure this, we'll select this AB line first and then this locus line. So this is around 12 degrees. So this is the value of beta and the value of phi is 11. So these are the values. So 71.59 is the apparent length of the line in the top view and 80.62 is the apparent length of the line in the front view, and it is always lesser than the true length as we have seen in the other problems also. So this completes the problem when the data of the end projectors is given and also the location of both the extreme points of the line is given to us without the data of any other true inclination or the apparent inclination and the true length and the apparent length. So this completes the problem. Thank you all for watching.